Interest means that you receive a percentage of what's called the principal, or the original amount, at some time interval. So the specific idea of receiving perhaps 5% interest on $2,000 would be to receive 0.05, which is 5%, of, which means times, 2,000, which is $100. So if you get 5% of $2,000, say in the first year, you would get $100 in interest. So if you put $2,000 into an account and received $100 of interest, you would then have $2,100 after 1 year if the interest was due to be paid at the end of a year. So various ways of looking at this. Something called simple interest would say, oh, every year we're going to get another $100 because that's 5% of $2,000. But compound interest, which is what we're interested in here, means that we now have $2,100 in our bank account after a year, and we should get interest on $2,100 because that's how much we have in our account. And we're getting 5% interest on our account. So, in this case, we would get 0.05 times 2,100, which is going to be $105 now in interest instead of $100 in interest. In other words, we're getting interest on our original principal plus all the interest we've gathered so far. So now our new total is $2,205, and we should in year 3, so that's after 2 years. So in year 3 we should start getting interest on $2,205, which will be more interest again than $105. So $2,205 at 5% interest is going to give us $110.25 in interest. And we can continue this process to get us now, of course, $2,315.25. Though the math gets messy, because we're getting interest on our interest on our interest, we get more money in our bank account and more interest each year as the amount compounds or builds upon itself. However, this seems like a really slow way to do this process, particularly if you do it for many, many years. So what's a faster way to do this? Well, $2,000 plus 5% of $2,000 is actually 105% of $2,000. You could view this as distributive property, where you take 100% plus 5% and get 105%, represented by 1.05, as we've done here, of $2,000. If you do this multiplication, you of course get $2,100, which is what we got after 1 year before. The beauty of this is that we can take $2,100 and multiply it by 1.05 again, and we get $2,205, which is what we got before after 2 years, after two years. And then we can take 2,205 and multiply that by 1.05, and we can get $2,315.25, which again is what we got after 3 years. In other words, you can just keep multiplying by 1.05 as many times as you get to collect your 5% interest. So even that feels fairly slow. If you're going to do it for 15 years, you have to multiply by 1.05 15 times. But to multiply by 1.05 and then multiply that answer by 1.05 and then multiply that answer by 1.05 and so on is no different from multiplying by 1.05 a bunch of times first and then multiplying that answer by your original deposit amount or principal amount of $2,000. So the faster way to look at this, because multiplication is commutative and we can multiply in any order, is to simply say, oh, we'll take $2,000, multiply it by 1.05 a bunch of times. Well, how many times? Suppose we were going for 8 years. So we would multiply it by itself 8 times, which is the same as saying 1.05 to the 8th power. As I've indicated here, this is to the 8th power for 8 years of compounding. In other words, 8 times that we multiply by 100, we find 105% of what we had before. So here's an example of a problem that we could do where we deposited $3,000 initially. So we would take $3,000 and we would multiply that by 107%, which is 1.07, because you're increasing 7%. So you take your original percent, which is 100%, and add 7%, which gets you 107%. And therefore you would have 107% of what you had before, or 1.07 times what you had before. And we're going to do this for 10 years. So we're going to want to multiply by 1.07 10 times. And fortunately, in scientific calculators these days, we have a button for this. You could simply multiply 1.07 times 1.07 a whole bunch of times, keep good track and make sure you did it 10 times. Or you can find the button on your calculator that gives you the exponent key. Sometimes that's an up caret, meaning that. And sometimes it's a y to the x or an x to the y key, depending on your calculator. So if I use the calculator to find 1.07 raised to the 10th power, I get approximately 1.96715 and some more details, which is now going to be what I'm going to call the multiplier, which I've boxed in, of $3,000. In other words, we started with 3,000, and at the end of 10 years, we're going to have 1.96715, etc., times our original amount, in this case, times $3,000, which is going to give us a total of $5,901 and approximately 45 cents. So you need to keep a nice accurate multiplier on your calculator, so best not to round that. You keep the answer that your calculator has and multiply by whatever your original amount was. But keep in mind that that multiplier simply says if you earned 7% interest compounded annually for 10 years, you would have 1.96715, etc., times what you originally started with.